This is a Ryan Little production.
Hello everyone, welcome to Prints for Science. In this tutorial, I am going to discuss about modifications of polyethylene terephthalate. What is modifications? Why? Generally, polyethylene terephthalate is a kind of textile fibers which having many advantages like strength, dimension stability, and for durability and etc. On the contrary, it having some drawbacks like poor dyeability or is very difficult to dyeing, and antibacterial properties it doesn't have as compared to other fibers which is called naturally extracted bamboo which having antibacterial, and reduce flammability since it's a synthetic fibers, it capture film very fast, and improve water absorbency which is called hydrophilicity, and improve some mechanical properties. So these properties is possible to just modify so that we can get these properties. Therefore, once we get these properties as per the applications, we get fully satisfied. Let's go what kind of modifications normally takes place for polyethylene terephthalate. So the first one, just change in the chemical compositions of polyethylene terephthalate molecule by introducing third or fourth component into the polymer chain during the polymerization. Some comonomers or some functional groups, and those things we can add during polymerization. And second, use certain additives like fillers or pigments of polymers which change the functionality of the fibers during the melt phase of extrusion. And third one, modification during melt spinning such as hollow or microlinear fibers. While production of the filament or in the fiber form, we have to change how we are going to manufacture, that I am going to discuss. And the fourth one is surface modification of polyester by using some specific effects, by using some plasma treatment or some enzymatic treatment or some other chemical treatments. This fourth one is after production. So the first and second and third one is before production of filaments. So by this way it's possible to do some modification in the polyethylene terephthalate. Let's go in the subject. The first one, modification, improve dyeability. So in generally we all know that polyester is very difficult to just a moment. Okay, so generally polyester is very difficult to do the coloration since it have higher Tg, and is usually people carry out the dyeing in with the help of high temperature and high pressure is around 140 degrees Celsius, along with the pressure is very high, is around 3.5 bars for in case of 100% polyester. So it's very difficult, and unnecessarily we are spending a lot of energy and so many things since we have to concentrate since because of global warming and many fact. So it's necessary to talk about all those things. So here the first one is the improved dyeability by reduce the glass transition temperature, which increase the dyeing rate because the polyester is around 80 to 90 degree Celsius as a glass transition temperature. So once we reduce this glass transition temperature, it's possible to carry out the dyeing with lower temperature as compared to 140. The most effective comonomers are aliphatic in the character, so that we can add here and replace the small proportion of terephthaloid units with aliphatic dicarboxylic acid such as glutaric or adipic acid. We have to add in the structure so that it will reduce the glass transaction temperature. Carrier free dyeable polyester, so it's called CFDP. So generally there are three methods which we use for without modification, so there is no modification. So in that kind of polymers, or maybe in the textile fibers, we can carry out the dyeing in three types. One is carrier dyeing, and second one is high temperature high pressure method, and third one is thermofixation. The carrier dyeing is we use some solvent or some carriers. Usually it is called the carriers. It is nothing but it's a swelling agent. So we use these agents to make the fiber to swell, so that the dye molecule can easily penetrate inside to the fiber. So these dyeing is carried out around 90 to 100 degrees centigrades. So we can save almost 40 degrees, which is very we spend a lot of energy to make 140. So that one is, but on the contrary, the carrier is like a solvent or some other chemicals which is mostly toxic, and it's problematic to the environment. So when we do some chemical treatment or some chemical processing, we have to consider environment. That's more important. So therefore we use carrier free dyeable polyester which replace the carrier. So we don't know to use carriers. So in normal dyeable polyester there are no sites in ionic dyes. In polyester it doesn't have any sites. Therefore we cannot able to use ionic dyes like cationic dyes or anionic dyes. It can only dye with dispersize. Yes, of course. Compared to the ionic dyes, dispersives have smaller molecular extensions and coefficients and lower built-up properties. Diablated boil without the use of carriers. So that is the main object for using this modification. So produced by adding certain additives like polyethylene glycol or adipic acid or azelaic acid to form some block conomers with the polyester with some ionic sites. So it is possible to dye. Therefore it's possible to dyeing at 100 degrees centigrade, and by using these agents it's make sure that when we add such comonomers or some functional groups, that will not disturb our the main properties, primary properties like physical properties and tensile strength and other things. That's more important. And let's talk about modification for hydrophilicity. So various process for making polyester fibers hydrophilic, including special finishing, non-circular and cross-sectional multi-layered structures, dyeing, finishing, and plasma treatment. Some of the important modification approach are discussed below in these sections. Yes, of course. And by using these techniques, it's possible to increase the hydrophilicity. Basically, polyester, which absorb only 0.4 percentage of moisture. So we have to improve. If once we improve, so it will be good when we wear. So there are some possibilities which increase hydrophilicity, like change the cross sections like non-circular, like trilobal or some other serrated structure, or 5-star or 8-stars like that structure, and some treatment surface finishing treatment like by using plasma. So that treatment can help to improve the hydrophilicities. Also, there are large number of additives are suggested to making polyester fiber to hydrophilic. So ICI company have suggested addition of 5 to 10% weight of sodium sulfate as a slurry in glycol during polymerization, which helps to increase the hydrophilicity. The particle size of sodium sulfate should be less than 3 micron, then only it will be good. So hollow polyester, which also increase the some amount of hydrophilicity. During the last few years, considerable amount of research work which has been done producing hollow fibers. So hollow is nothing but which having small holes in the center of the fiber, or maybe in the side, or whatever it may be. You can see here different type of hollow fibers. The hollow polyester is produced by using specially designed spinneret, and normally 4 types of spinnerets are used for producing hollow fibers. So you can see here these are all the designs of spinneret. Antibacterial polyester modification fiber providing antibacterial protection. Generally, the polyester is a synthetic fiber which doesn't have antibacterial properties as like other fibers, other natural fibers, particularly in the naturally extracted bamboo. There are two types of bamboos. One is regenerated bamboo and another one is naturally extracted bamboos. The naturally extracted bamboo which having the antibacterial properties, which doesn't have the which properties the polyester doesn't have. So that properties we have to add by using some specially additives. So it is common practice to give antibacterial properties to synthetic fibers by adding organic additives combined with the fibers in several ways. However, employing the organic agents to provide antibacterial activities is to some extent unsatisfactory because still it is in research and development, still it is not successfully, or maybe in the laboratory level, not in commercial. So next is a flame retardant polyester fibers. Generally it is a synthetic fiber which having is the lowest limiting oxygen index, so it is necessary to increase some additives, increase the flame resistance by using some additives or some other ways. A number of flame retardant polyester fibers are commercially available. That's more important. The number of flame retardant additives used during esterification reactions are in the polyester, sometimes mixed with the polyester chips before melt spinning. So these are all the some additives which we can use for getting flame retardant polyester. Since there are some additives having lack of problems like environment and toxic in nature, so the inorganic supports such as specially zeolites and ceramic substrates containing Ag or zinc ions have been proposed to use. And the next one is the bicomponent fibers and microfibers. Bicomponent means heterophile fibers, which are the filament made up of the different polymers like sea island or some other things, or different structures you can see in the next picture. So here you can see the core sheath fibers is 50 and 50, and here you can see core sheath ratio is 20/80, is eccentric. Of course it's a core sheath but eccentric, and it's a trilobal with inside is different fibers and outside is different fibers. So there are different kind of bicomponent fibers it can be possible to manufacture. What is the advantage of these bicomponent fibers means, for example, here is a 50/50, like inside 50 it is possible to manufacturing a nylon and outside maybe polyester. So we get in the same fibers we get the both the properties, so that is the most advantage. So according to our applications we can decide so what kind of fibers we can manufacturing. So types of bicomponent, and you can see the different kinds. So microfibers is micro, which is having very lower denier. So what is advantage means, for microfibers having more surface as compared to the normal conventional fibers. When it having more surface, it have absorb more water, as well as if we go for some applications like for filtration and all those things, the microfibers having good efficiency than the conventional fibers. They are very flexible, giving soft hand and excellent drape to the fabrics. The high density of fibers, the typical microfibers makes the fabric makes inherently windproof and waterproof, as I said before, because the filtration efficiency is very good here. So these are all the some modification of polyester.
This is a Ryan Little production.